Okay, so we've got places here, 2-mark question. We just want to find by inspection. So in other words, just by trial and error, by using your own method. There is no set method. Just try and find it. Minimum time to walk from AP to SB. So on the minimum time from AP to SB. So just try out all the routes. We've got 8 that way. We've got 9.5 that way. We've got 8.5 that way. And then it's going to be a lot more that way. So it looks like we can do it in 8, and I think we're still in minutes, so 8 minutes. And state the route compared to it for it. So the 8 came from doing that way. So we went AP, again we've got to write both sets of letters, MC, and then to SB. So it's a bit of a strange question, but I suspect we're going to use it later on. Now we're using Dijkstra's algorithm, and we want to find the shortest time from MT, so we're starting here, to KK, so ending here, showing all temporary labels. So we're starting here, so we'll put a 0, box it, go everywhere we can from here, which is just there. That's our lowest one, box it, everyone from there, which is just as there. It's not very exciting so far. Box that one. Go everywhere you can to from here, so 3.5 plus 7 is 10.5. 3.5 plus 2 is 5.5. Pick the shortest, pick the smallest of those which are unboxed, or pick the 5.5 and we'll box it. Go everywhere from there, so 5.5 plus 2 is 7.5. We don't go back to anything already boxed. 5.5 plus 6.5 is 12. Because 12 is bigger than 10.5, do not replace it. Leave the 10.5 as it is. Pick the smallest unboxed. We're going to pick the 7.5 and we're going to box it. Plus the 4.5, that's 8, 9, 10, 11, 12. We'll put that there. Plus on the 3.5, that'll be 11. So everywhere we can go to from there. Pick the smallest, which is a 10.5, and box it. Everywhere we can go to from here, so we can go up to here, and that would take us 19. We can go plus the 1, so it gives 11.5. Because 11.5 is smaller than 12, we'll cross out the 12 and replace it. We can't go back there because already boxed. Pick the smallest of these. We're going to pick the 11 and box it. Plus on the 6 to go this way, that'll be 17. Plus on the 2.5 to go that way, 13.5. Plus on the 4.5, that would go to 15.5. That's bigger than the 11.5, so we don't replace it. Smallest out of these 3 is that one, so we'll box it. Plus on the 5.5, so that would give us bigger than 13.5, so we don't replace that. Nowhere else to go. Smallest of these, box it, so 13.5. Add on the 6, that will give us 19.5. Add on the 2.5, that will give us 16. Add on the 6, that gives 19.5, which is bigger, so we won't replace it. Smallest out of all of these 4, this one here. If we plus 8, it's bigger than 19.5. Plus 5, bigger than 17. Smallest out of all those unboxed, this one here. Nowhere to go from here, so we'll just box it. Smallest out of these 2 unboxed is a 19.5, so we'll box that, so we'll make that one 24 and that one 20.5, and then smallest after all of these unboxed is that one there, so we'll box it. We now stop the algorithm because we've got to KK, we've got to where it wanted us to go to. And Dijkstra's algorithm works where you get to the point it says to go to, you end it. So you need to be careful that you don't box the 20.5 and the 24, that you don't continue the algorithm. It must look just like this. You've only got one crossing out as well. So you've only got a crossing out here. Everything else has got no crossing out, it's just boxed. So you're checking to get your full marks. You've got one crossing out there, you've got a 19.5 here, and you've not got these 2 boxed. So state the route corresponding to this time. So if we go back, so we're at KK, and then we work out where we go to by our subtraction. So minus 8 isn't that, minus 6 is 13.5, so we came from SH. So at 13.5, if we minus 2.5, we come to 11, so we've come from the KC. If we minus 4.5, we don't get that. If we minus 3.5, we do get that, so we've come from RM. If we minus 4.5, we don't get that. If we minus 2.5, we do get that. So we've come from AT. If we minus 2, we get to our AP. Minus 1.5, we get to BP. And we started at MT. So if we minus 2, we get to MT. So that's our roots. Part C. So there's a shortcut now by joining AP to SB. So suspiciously, they were the same two places you looked at in part A, and that shortcut is X. So if you use that shortcut, the minimum walking time from AP to SB is reduced. So we know the minimum walking time from AP to SB was 8, but if we use that shortcut, it's reduced. So what we do know is that X must be less than 8 because it would reduce it, so it would make it shorter than what it already is there. So X must be less than 8. But the minimum walking time from MT to KK is not reduced. So from there to there is 19.5. If we use the shortcut, it's not going to reduce it. So if we use that shortcut then, we start at MT, it would take us 3.5 in order to get to AP. We use the shortcut, so we're going to go up the shortcut, so we'll add on our X, and we're here. And now we want the shortest distance to get from here to KK. So it looks like it's going to be this way here. So the 5.5 to SH, so plus 5.5 to SH. And then it's going to be to add on the 6 here, so add on the 6. And that will get us to KK. And all we know that it is not reduced. So that distance there has to be more than 19.5. Or it just says not reduced. It could equal 19.5. But that distance there is not less than 19.5. So if we add these up, we've got 5, 8, 9, 15. So we've got 15 plus X is bigger than or equal to 19.5. Solving that, we've got X is bigger than or equal to 4.5. And then we want to put them together. So we know that X can be less than 8. X can be bigger than or equal to 4.5. So we're going to write it as one inequality, so it's going to be less than 8, but bigger than or equal to 4.5. And in order to check your answer then, for your full marks, you need to make sure this is a strictly less than sign, whereas this one is a less than or equal to sign, so you've got the equal on the bottom of there.